The work of Nobel Prize has transformed our understanding of the world. While approaching the Nobel Prize winners in chemistry, we not only learn their achievements, but also the spirit of honesty, tenacity, innovation, and forging ahead.
Hi everyone, welcome to today's class, Approaching Nobel Prize Winner in Chemistry. 同学们大家好，欢迎走进今天的课堂，走进诺贝尔化学奖。Today I will introduce you the father of macromolecular chemistry, who is Hermann Staudinger. 今天我会向大家介绍一位不随波逐流的高分子化学之父——赫尔曼·施陶丁格尔。In our daily life, we are all familiar with the products made of plastics, synthetic rubber, and fibers. But do you know they are all macromolecules, also called polymers? Today, we are going to talk about the greatest scientist who was the pioneer for macromolecules. Hermann Staudinger demonstrated the existence of macromolecules, which he characterized as polymers. For this work, he received the Nobel Prize in Chemistry in 1953. He's also known for his discovery of ketons and of the Staudinger's reaction. Staudinger was one of the most influential organic chemists of the 20th century. He is considered to be the father of macromolecules, also as polymers. His work laid the foundation for the great expansion of the plastic industry later in the 20th century. Staudinger's work on polymers began with research he conducted for the German chemical firm BASF on the synthesis of isoprene. Isoprene is the monomer of which natural rubber is composed. Staudinger's pioneering work provided the theory for polymer chemistry and greatly contributed to the development of modern plastic. His researches on polymers eventually contributed to the development of molecular biology. For example, he discovered the ketons. Keton is an important intermediate for the synthesis of the production antibiotics such as penicillin and amoxicillin. As for now, you may ask, what is a macromolecule? Let's see what Staudinger says. He said macromolecules were long-chain molecules of identical or nearly identical units that were linked by covalent bonds. But at that time, most organic chemists believed that the rubber and other polymers were composed of small molecules held together by non-covalent bonds. Staudinger proposed that the polymers are actually giant molecules, which is known as macromolecules, that are held together by normal covalent bonds, a concept that met with resistance from many authorities. So there was a big debate between Staudinger and other leading organic chemists. Despite the attacks, Staudinger was determined to prove his point of view by experiments. He carried out a series of experiments to yield more understanding of the chemical and physical properties of polymers. He gathered more evidence by synthesizing polymers from formaldehyde from styrene. The homologous formaldehyde-derived polymers span the molecular size range from small molecules to large macromolecules. From the results, Staudinger concluded that polymers were molecules whose repeating units by covalent bonds, and they have characteristic functional group at their ends. The polystyrene polymers were prepared under different reaction conditions and had a range of molecular weights and physical properties. This data was also consistent with covalent bonding but not with colloid association. Staudinger's ideas were gaining popularity, but it was a 1928 paper by Dr. Mark and Dr. Meyer that finally convinced the chemists that Staudinger had been right. They used X-ray crystallography to probe the structure of crystallized polymers. They found that polymers were indeed long-chain molecules in which repeating units were linked by covalent bonds. So from Staudinger's findings, nowadays we all know that polymers are made of series of the same small unit as many small beans on the string are connected making a rosary string. For example, polyethylene, PE, is the most widely used plastic all over the world. It's made of repeating methylene group CH2 and is synthesized by the addition of polymerization of ethane. PE is mainly divided in two types. Low-density PE, known as LDPE, is commonly known as high-pressure polyethylene. It's a low-density and very soft material, so it's mainly used in plastic bags and films. High-density PE, known as HDPE, is commonly known as a low-pressure polyethylene. Compared with low-density PE, it has high temperature resistance, oil resistance, environmental stress crack resistance, and so on. They are often used in molding and other fields. So for today's class, we have got to know the father of micromolecular chemistry, who had a great impact on our daily life. Thank you for watching.
大家好，高分子材料、金属材料和无机非金属材料是当今材料世界的三大支柱。它们以各自的特点满足着人类多方面的需要。但是，没有斯陶丁格尔，就不会有合成聚合物，更不会步入新材料的时代。1920年。施陶丁格尔经过深入的研究后，发表了《论聚合》的论文，提出高分子物质是由具有相同的化学结构的单体，经过化学反应，通过化学键连接在一起的大分子化合物。1922年，施陶丁格尔提出了大分子理论，动摇了当时的传统胶体理论，并随之与胶体论者展开了激烈的辩论。正是由于施陶丁格尔的出色工作和坚韧不拔的科学精神，才得以创建高分子科学这一新兴的学科。随着塑料、合成纤维、合成橡胶三大合成材料的诞生，科学技术成功解决了地球自然资源不敷人类之需的难题。施陶丁格尔有句名言：“我站在科学道路上，我别无选择。”好了，本次课到此结束，谢谢大家，再见。